So as promised, we're going to continue with number 4 if you need to see more of this. Really, a lot of this is about setting your window. So if I'm going to take this and take a second, read the problem. You've got bailing out of the airplane and surviving the fall. Little side comment, this made me spend like tons of time on Wikipedia last year looking at people who fall and survive without parachutes. It's really kind of weird. He's not even the one who's fallen the highest. You know, that's 4 miles in the sky. So weird. Just read about how he did it. I know you're kind of curious, because I was. But here's his arc function. So I'm going to take that and plug it in. Negative 16t squared. I'm going to pause this while I do it. Okay, so I actually put that in. And as you can see, yeah, I can't see anything. That's because my y is not nearly high enough. My y-intercept is 21,980. So I need to change my y. Oh, let's see, look, I can drag this, but that's not helpful. I need to change this to maybe 30,000. I don't even think that's going to be high enough, but let's try it. Well, no, it was high enough. And if I kind of slide this over, I see I made more room on my x-axis. So, oops. Okay, so I'm going to change the x-axis to be maybe like 50. Ooh, good graph. So this is kind of good. That's good enough because if I go back to this, my t is in time, and t is the number of seconds, and it actually says t in seconds. So I really only need a quadrant 1 graph so I can see a situation of this. Sorry, just making sure this is recording. So let's see what it wants. It wants at 5 seconds how far above the ground was Mr. Chisov. Well, I can do this by going menu, analyze graph, just kidding, trace, and then type in 5, and then press enter, and it gives me a point of 2.16 times 10 to the 4th. I don't like that. Let's go and change the default so that never happens again. So what I'm going to do is I'm going to escape, pretend like we didn't do that. I'm going to go into this drop down and go to settings and change the document settings. Let's change my display digits to, hang on, I'm going to confirm this works. Kidding, back out of that by hitting escape. I found it, and I'm excited I found it. So here's where it is. Let's go menu, and I'm going to go down to settings, and then I'm going to change the display digits to, let's just go float, let's go float 6. And then I'm going to hit make default, and now let's try what happens. When I go menu, trace, and hit 5, yay, now it gives me an exact value. This is kind of better for me. So that should answer your question, John. Hopefully you're seeing this. Again, that was menu, settings, and then change it to float 6. And then hit make default. So that's going to change it for all the documents that we would create from now on. So that problem solved. That's one way to do it. And I'm just going to leave it there. That's an answer to the question. 21,580 feet. So at 5 seconds. Oh, wait a minute. This says after 5 seconds. Let's see. Relationship between the height. Oh, that's right. Sorry, I'm being weird. After 5 seconds, he is at that height. So what was that? 21,580 feet. I was trying to make sure that wasn't like something different. How many seconds did it take for him to fall 10,000 feet? Okay, this is the weird question. So to fall 10,000 feet, well, when he falls 10,000 feet, I know that at t equals 0, he's at 21,980 feet. So if he's falling 10,000 feet, basically I want to figure out where he's at 10,000 less than this, which is 11,980 feet. So I'm going to go ahead and graph y equals 11,980. So tab, it's doing that freak out thing, sorry, 11980. Boom, got that. Then I'm going to go menu, analyze graph, intersection, left bound, right bound. Move that point up, 11, let's see, that's 25. So that was at t equals 25 seconds. And how many seconds did he fall before reaching the ground? Well, that should be easy. That's way down here. So there's two ways I can do this. Probably the easiest way right now is just go to Analyze Graph and 0 and do this graph 0. So I have to click on the blue graph because it's saying which one? That one. And then left bound, right bound. And it gives me the 0. I can drag that up and see that that was at 37.1 seconds. And so I would say that's at t equals 37.1 seconds. Another way people can do is they sometimes like to graph as a separate line. And I'll just show this. Y equals 0. Sorry, we'll try that again. And they put a line there, and then just do an intersection of those two. I'm going to delete that because I don't really need to see that. So that's that problem. I'm going to add a new page for the next problem. So go back, add a new graph, and now let's go to here, number 5. Right, the quadratic equation that needs to be maximized. Okay, it says a pen is to be built along a wall from 72 meters of fencing. We've actually seen problems like this before when we did factoring. So here's 72 meters of fencing. And I know if I call this x, and basically, if that's 72 total millimeters of fencing, this is now 72 minus 2x. Because the whole thing is 72, and if I subtract off the two other parts, that gives me an expression for that side. So, if a pen is to be built along a wall from 72 meters of fencing, I'm going to presume it wants the area function, because that's going to be the quadratic. So area is equal to x times 72 minus 2x. And it says determine the value of x that maximizes the area. Well, that's a quadratic function, and it's going to look like that. So I'm going to just graph this into my new graph. X times 72 minus 2x. X times 72 minus 2x. And I get something I can't see, which is par for the course on this. Well, I know that one of my zeros is 36, so I'm going to actually expand this a little bit to show that. It's going to bring that to 40. And I should see that coming down. So basically, I need to get way up there on the y. So let's change the y to maybe 100. And this is actually how I sometimes do it if I really don't know. Change to 1,000. There we go. I'll just move that here, and that's good enough to see. I kind of just shift the graph around. You can actually click on the background and drag the graph anywhere around if you just want to kind of adjust it a little bit. So then I'm going to find a maximum. Menu, analyze graph, max, left, right, and I've got an ordered pair of 18,648. So let's go back to here. The value of x, that would be x equals 18 meters. And that's the value of x. That would maximize the area. And by the way, the max area would be 648 meters squared. Finally, it says the sum of two numbers is 30. Find their greatest possible product. So then we say xy equals product. What are the numbers? Well, if that's true, I can do a substitution. So that's equal to x times 30 minus x. And so if I'm trying to find the greatest possible product, basically I want to find where the values of x and y, where the vertex is. And that's a downward parabola. Now, I'm going to kind of show you something here by hand. You know the zeros of this function would be 0 and 30. You'd also know that right here, that would be 15, halfway in between. And so if I plugged 15 into here and here, I would get 15 times 15, or 225. So really the numbers are 15 and 15. I'm going to prove that with a graph. If I graph, and let me put a new graph in. If I graph x times 30 minus x, and again I need to expand that out, so let's make that about 300. And then let's make this one, that needs to be at least 30, so let's go 40. If I do a maximum of this, so analyze graph, max, left, right, yep, got 15 for x and 225 for the product. So that confirms what we just did. Now I'm going to pop over and do number 1 on the homework, just so you can kind of start this. This is from my period 1 this morning, due mañana, that means tomorrow. Just be careful with your graphs and stuff. So number 1, gateway arch. This is the St. Louis arch. This is the equation for the St. Louis arch. So let's go ahead and plug that into the calculator. I'm going to pause it while I put it in. I'm back. I plugged it in, and I see nothing. But I look at this, and I know that the vertex of this equation is at 315, 630. And so well, hang on. So what we need to figure out is how to graph that with 315. My x needs to be at least 315, if not double that. Probably needs to be double that because that's its vertex. So let's maybe go 700 for x and just kind of see what we see. That might be too big, but 700. Don't see a lot. Let's go back up to here at what should that be? That should be 630. So delete. Make that 700 as well. Oop, not 7,000. Ooh, and I got a horizontal line. Oh, and I can see why. I did not put the square in. I was actually just talking to a student who might have forgotten to do that, but that's me. Okay. There we go. Now it's bending. My graph was actually kind of okay. And so let's answer the questions based on the graph. If the x-axis is at ground level, what is the height of the arch? Actually, I could have answered that right here. Since my vertex is 315, 630, my height is 630 feet. And then how wide is the arch at its widest point? Well, its widest point is the ground level itself. So if I kind of look at this this function, let's go back to the graph. Oops, sorry. No, not there. Right here. I need to figure out what the zeros are. So I think this is crossing through 0, 0, but let's just check. If I go to analyze graph, 0, left, right, yep, 0, 0. And if I go right here to analyze graph, 0, right there, barely caught it, it's at 630. Well, that's double the 315, so that makes sense. Basically, if the arch has its vertex at x equals 315, then really double that should be 630. And so the widest is 630. And there weren't any units on the x-axis, but we'll just call it feet, because maybe we mean feet. I'm not sure. So isn't that fascinating? I mean, I think it's fascinating that its widest at point and its height are the same number. Okay, I just think that's weird. So go from there. That's all. But I will see you guys tomorrow morning. Be there at 7:30 if you have questions.